When an administrator deletes a digital identity, the interface disappears instantly. To the user, the object is gone. But in a distributed database, immediately erasing a record from a single node guarantees it will be overwritten by a peer server that still holds the active profile. Immediate physical deletion is mathematically impossible without causing directory-wide chaos. The fragile fragments must remain suspected in place. In Active Directory, executing a delete command does not erase an object from the hard drive. Instead, it triggers a strict state change within the database. The live entity is stripped of its attributes and converted into a tombstone. A tombstone is a dormant, minimal version of the original object that takes its exact place in the directory structure. This remnant is an active data vehicle. Its sole engineering purpose is to carry the news of its own deletion across the entire network, forcing every other connected server to acknowledge the change. Every interaction with a removed account relies on this dormant architecture. Recognizing that a delete command is an active broadcast rather than an erasure prevents administrators from making assumptions that cause silent directory corruption. When a user object becomes a tombstone, the system modifies its internal metadata, flipping its isDeleted attribute to a true state. It immediately relocates this flagged object into a hidden deleted objects container, a dedicated vault maintained by every directory partition. Once sealed inside this container, the tombstone becomes completely invisible to standard LDAP queries. LDAP, or Lightweight Directory Access Protocol, is the core language applications use to search the directory. Administrators can only expose these hidden objects by executing searches that utilize a highly specialized LDAP control code, specifically 1.2.840.11356.1.4.417. There are strict architectural exceptions to this lifecycle. Protected configurations like NTDS settings, dynamic objects with a time-to-live setting, and scavenged DNS records bypass the tombstone phase entirely. Time to live is a programmed countdown that dictates how long a dynamic object remains active before it is automatically and instantly purged. For standard objects, this hidden graveyard is an absolute requirement. It serves as the single mechanism that allows a sprawling network of disconnected servers to eventually agree on what no longer exists. Moving past the individual object, we must examine its complex web of network relationships. Group memberships are the most common linked attribute in a directory. This diagram shows the relational architecture. A directional arrow points from the group to the user, acting as the forward link. A return arrow points from the user back to the group, acting as the backlink. The engineering challenge is managing what happens to this interconnected web when the central user object is suddenly deleted. In legacy environments, without the Active Directory recycle bin, the result is immediate destruction. Both the forward and backward links are completely severed. This destruction replicates across the network. If a severed linked value reaches a new domain controller, it is silently dropped from the local database, leaving zero historical trace of the relationship. This poses a severe risk during an authoritative restore. If a restored group replicates before the user object arrives, the membership is permanently destroyed because the destination database lacks the target user record. Without a metadata safety net, deleting a single node directly threatens to unravel the integrity of the entire relational matrix it belongs to. The modern architectural solution to this linked value problem is enabling the Active Directory recycle bin. The recycle bin is an optional feature that preserves deleted objects and their exact attributes for full restoration. With the recycle bin active, links pointing to a tombstoned object are not dropped during replication. Their internal database status is merely shifted to deactivated. This generated image shows the forensic reality of a deactivated state. On the left, the graphical interface shows an empty group, but command line tools reveal that deleted member links are still listed as present on the backend, stored with mangled, scrambled alphanumeric names. This differs entirely from a simple removal. If you remove a user from a group without deleting the user itself, a different mathematical process occurs. In environments operating at a Windows Server 2003 functional level or higher, the user's link inside the group's attribute is specifically marked as absent. This allows the removal condition itself to replicate across the network on a precise per-value basis. Tracking these granular changes creates a critical operational constraint regarding scale.
Modifying or deleting more than 5,000 members in a single transaction will overwhelm the database with long-running transactions. To prevent severe network bandwidth consumption, massive group modifications must be executed in distinct batches of fewer than 5,000 members. Preserving the detailed history of relational links and the exact history of their removal requires immense background computation. It makes large-scale directory changes mathematically expensive. Zooming out reveals the macro mechanics of global synchronization. A tombstone is a temporary vehicle governed by a strict countdown called the tombstone lifetime. This diagram shows 3 domain controllers syncing. A unified timer ticks upward. By default, tombstone lifetime is 60 or 180 days. This timer mathematically guarantees the tombstone exists long enough to propagate to every partition replica, surviving global network latency. Once the timeline runs out, the object enters garbage collection, the automated process that removes expired records. At exactly the moment the tombstone lifetime expires, garbage collection triggers, physically purging the tombstone and related absent values from the drive. This hard expiration creates a strict backup limitation. Active Directory actively prohibits restoring data from a backup image that is older than the tombstone lifetime. This rigid expiration protocol is a vital mathematical constraint. It prevents a distributed database from infinitely expanding with the data ghosts of deleted objects. The most dangerous edge case in Active Directory management occurs when the replication timeline breaks down entirely. If a failure severs a domain controller, an object deleted on the main network becomes a tombstone and replicates to healthy servers, but fails to reach the isolated node. Later, the tombstone lifetime expires, and garbage collection erases the tombstone on the healthy network. Eventually, the broken server is repaired, powered back on, and reconnects to the network. The reconnected server now injects a lingering object into the environment. A lingering object is an outdated, fully active replica of an item that the rest of the forest has permanently purged and forgotten. If an administrator modifies this outdated lingering object, it forces the deleted entity to resurrect itself, copying the ghost record back across the entire directory. Modern Active Directory environments enforce strict replication consistency to prevent this exact disaster. By default, newly created forests will deliberately halt inbound replication if they detect outdated objects attempting to synchronize. Strict adherence to the replication timeline is the only safeguard for a distributed network. Slipping past the tombstone lifetime turns a simple localized server outage into forest-wide corruption. Because time is the critical failure point, the system requires an automated failsafe to warn administrators before the timeline collapses. This failsafe is the backup latency interval. It is a precise threshold programmed directly into the system registry parameters to monitor network health. This threshold is mathematically hard-coded to trigger at exactly the halfway point of the forest's tombstone lifetime. If a directory partition goes entirely unbacked up past this critical halfway mark, the system fires a specific warning, Event ID 2089, into the directory service event log. This event will trigger every single day until a successful backup is completed. It is a glaring, unavoidable alert designed for infrastructure teams. System backups must be executed at a drastically higher frequency than this halfway warning to ensure viable, safe restoration points exist when disasters occur. The life cycle of a deletion requires heavy, automated orchestration. It transitions objects to tombstones, manages relational linked values, enforces replication delays, and executes physical garbage collection. Active Directory prioritizes absolute global consistency over localized storage efficiency. Respecting the rigid, unforgiving mathematics of the tombstone lifecycle is the only way to maintain the integrity of the enterprise.